you look at 10. My question is, this U is this vector minus 2, 3, and 1. And then A is that in exercise 8, determine if U is in the null of A. So what you do is you take A times U, and it should equal 0. And then that would show them that U is in the null. So the vector A is, or the matrix A, minus 3, 0, 6, and minus 2, 2, 3, and 0, minus 6, 3. And then U is going to be a minus 2, 3, 1. So you multiply the 3 times the 2, so you get 6, and then minus 6, that's this term times that term, and then 0 times 1 is 0, and then you multiply the second row times that, so then it's 0. Well, this is 0. This would be 0. Then 2 times the 3 is 6. And the minus 6 times the 1 is a minus 6. And then the last row times that is minus 12. Plus 9. Plus 3. And so what you have is 0, 0, 0, and therefore you could say U is in the null of A. Now the next two exercises, 11 and 12, says give the integers P and Q such that the null of A is a subspace of R of P and the column A is the subspace of Q. So 12. And we're given this matrix. It's 1, 4, minus 3, and 2, 2, 5, minus 1, 7, 3, 7, 0, and 11. Okay, this should be a negative 5. Okay, that looked like a negative 5, good enough. Okay, well, this is a 3-row, 5 and 4 row. If I can get this right. This is a 4-row by 3 column. And for something to be in the column A, column A takes columns of these. So column A, the R has to be 4. It has to be in the space 4, because you're going to take any one of those columns to be in column A. And what it would be is if you did an echelon of this, the columns that would be in column A would be the ones where you have the pivot points. So if you did a echelon of it and you found that column 1 was a pivot point, then column 1 would be in column A. If column 2 didn't have a pivot point in it, then column 2 wouldn't be in column A. If column 3 had a pivot in it, then it would be 1 and 3. So it has to be in R4, because there's going to be 4 entries in those columns. And to be in null A, what you do is you have to multiply A times some X equals 0. Well, that means that this X is going to have the same number of elements in it as there are columns. So this would have to be in R3. Does that make sense? And then what you would do when you did this, you would do a reduced row echelon of this thing, and then you would do parametric equations, and if it didn't have a diagonal of 1s, you do parametric equations, and then the vectors that are in it are the vectors of that parametric equation. When you do x1 vector, x, whatever it was, those vectors would be the null of A. Does that make sense at all? So I guess in answer to this thing, the P would have to be 3 and the Q would have to be 4. Isn't that right? Yeah. Because the P is the space of the null, and the Q is the space of the column. All right. It says for A in exercise 12, I'm looking at 14. Find the non-zero vector, find a non-zero vector in null A and a non-zero vector in column A. So you kind of do this at the same time. Let's see, this 12. So I'm going to do one, 4, 5, 2. What I'm going to do is I'm going to do an A, augment it with a 0, because to do the null, right? Because A x equals 0, null, 2. 2, 5, 7. Now to get the null of A, and what I'll do is I'll slip back when I get to a certain point, and then I'll get a vector for column A, because I want one vector for column A and a vector for null. What I got to do is to get this thing in reduced echelon form. This is going to be 0, so I'm multiplying the first one by minus 4. It's 8 minus 3. The first one by 5, so it's 0. Minus 9. 0. The first one by minus 2. 0. This is 3. Minus 6. That's 5. A little digression. All right, so then we got to go 1, 2, 3, 0. I'll just 0 minus 3. Then I'm going to take 3 times the second, so that's 0. That's 0, right? 0. Then take 1 times the second. 0, 0, 0, 0. All right, now, right now, we can see that this is a pivot column and this is a pivot column. So for my column A vector, for a vector in column A, it's going to be either one of these two. See, it's whatever the pivot columns are the vectors for column A. Now then, in order to get them, so I'm not going to write down, it's either, you just pick either one. Either one of them be an answer. Because it says find one vector for column A. Well, it's going to be whatever the pivot columns are of the original matrix. That's what, it should span, this would span R4. Now then, we just go on, we got to get the null. So then, now I'm going to go 1, 2, 3, and I'm going to divide by, I guess I divide by -3. 1, and this is going to be 5/3, 0. And now I got to get rid of this 2 right here. So then I'm going to multiply the second row by -2, 1, 0. So that's going to be a minus. This one's going to be 3 minus 10 over 3, right? So I'm doing it up here so I can count. So it's 9 over 3 minus 10 over 3 should be a minus 1/3. Is that right? 0. Then it's 0, 1, 5/3, 0, 0, 0. Now then, what you do is you do parametrics. You'd say x1 minus 1/3 x3 equals 0, right? And then x2 plus 5/3 x3 equals 0, and then x3 is free. See, because of my original matrix was the 3, right? This is augmented, so it's just 3. So it just has x1, x2, x3. Now then, that says that x1 equals 1/3 x3, x2 equals -5/3 x3, and x3 is free. So if I do any vector x1, x2, x3 that's in the null, then I pick x3 to be whatever I want. Now that, and then I'm going to insert here minus 5/3 of x3 and 1/3 of x3. Well, what is the most convenient thing to pick for x3? 3. Because then it would be, and if I did that, then this would be 3, and this would be a minus 5/3 times 3, and this would be 1/3 times 3. So then I would have 1 and minus 5 and 3. And this is going to be a vector in nullity. Does that make sense? So you can kind of, to get this question answered, you can kind of go on your way to getting null A, right? Because here, you go to this point and you find the pivot points, and then you pick one of those vectors, and it's going to be one of those two red ones, and then you finish it off and do your parametrics, and then just pick for your free. Just pick one. All right, any questions on that? Now, in that next 15 through 20, it says, determine which sets in exercise 15 through 20 are bases for R2 or R3. Justify your answer. Well, if you look at 16, you have these two vectors. this is the problem with this thing. If you take a negative 1/2, the scalar, times a minus 4 and 6, you get what? 2 and minus 3. So they're not independent. So vectors are not linearly independent. And therefore they cannot be basis for a subset. And the definition is on page 150. If you look back at 150, it says the null space of a matrix A is the set A of all solutions of a homogeneous equation AX equals 0, and those are not linearly independent and they cannot form that basis. I guess it's more the bottom of the page. The basis for the subspace AH of Rn is a linearly independent set in H that spans H. So they've got to be linearly independent by that definition. I think it's bottom of the page. All right. All right, the next one, 18. Now what we do is we'll take these vectors, 1, 1, minus 2, put them in a matrix. And if we can show that that array is invertible, then by that exercise 5, page 150, example 5, excuse me, it says the columns of an invertible n by n matrix form a basis for all Rn. So we can show that that is invertible, then we have a basis. And we can, if we do an echelon form of that, and if we have a diagonal of pivot points, then if we go back and look at that theorem 8, page was theorem 8 on it. And notice theorem 8c says, it says if A is an n by n matrix, and then C says A has n pivot positions, then you can go back to theorem 8a. A is invertible, and then you've shown it invertible. So if we can show that that diagonal is all pivot points, because this is a 3 by 3 square, then we can show that it is invertible. And if it's invertible, then by that example, the invertibles are going to be, we're going to have proven that this is what they're wanting us to prove. Forms a basis. Okay, so we're going to do that. 1 minus 5, 7. Oops, I want to get that to a 0. Minus 1 times the first, so that's 0. Minus 1, that's going to be a minus, plus 5, plus 4, minus 7. And 2 times the first. Minus 8. Zero, 2 times the middle row. 0, 14, minus 5. Now, we have a pivot point on the diagonals, and theorem 8 on 114 says we have A is n by n square, and A has n pivot points. And if you want to insert this is a 3, but this one's a 3 by 3, and it has 3 pivot points. And this is theorem 8c, and it follows that theorem 8a is true. So it has, A is invertible. Okay, if that's true, and if you look at example 5 on 150, it says the columns of an invertible n by n matrix form a basis for all of Rn. So therefore, by example 5, the vectors form a basis for R3. Okay. So any questions on that? No, 20. What you're given is that 1 minus 6 minus 7, 3 minus 4. Now, there's, they're asking you for, are they bases for R2? R2 or R3? Well, they can't be column bases because they have 3 entries, right? Each vector has 3 entries. Let's see. Well, it could be that, but it couldn't be a null basis because there's 4 vectors, and it would have to at least be R4 space. And so then we look at theorem 1.7 on page 60. Theorem 8 on 60. It says if a set contains more vectors than there are entries in each vector, then the set is linearly dependent. So that any set V1 through Vp in Rn is linearly dependent if P is greater than N. So it's a linearly dependent set of vectors. Section 1.7 on page 60. And then if you look at page 150, it says the definition there says a basis for a subset H, Rn is linearly independent. Now, let's see how we're going to say that. Therefore, by definition, page 150, vectors do not form a basis for R3. And if it, you know, in the null can't be, because that has to be an R4 space. So this is not a basis. Okay, 22 says a subset H of R is a subset if the zero vector is in H. Well, if you look on the subspace. So if you look at the definition of subspace, on page 148. Notice there are three criteria. There are three criteria. Not one. Therefore, a statement is false. Because it says for a subspace, it has to have zero vector. Well, that's what this statement says. But it also has to have if there's vectors u and v, the sum has got to be in the subspace, and the scalar multiples have to be in the subspace. So it can't just be the zero vector. The B part there. Says given vectors v1 through vp in Rn, the set of all linear combinations of these vectors is a subspace of R. Well, it's true. Because if you look on page 149 and above example 4, it's telling you that that's a true statement right there. C, null space of an m by n matrix is a subspace of Rn, and that's true. And that's theorem 12 on page 150. Says the null space of an m by n matrix is the subspace of Rn. So that's just that theorem. D, the column space of matrix A is the set of solutions of AX equal B. And that's a true statement. And that's exercise 5 on page 150. It says the columns of invertible matrix are the space, so it's showing it there. And E is also true. if B is in the echelon form of matrix A, then the pivot columns of B form the basis of column A. And that's theorem 13. Notice it says the pivot columns of the matrix A form the basis for the column A space of A. And then 24. It says display a matrix A and an echelon form of A. Find the basis for column A and a basis for null A. So what they have, -3, 2, 3, 9, -2, and then they're doing this for us. They're getting this into 1, 3, 6. Now you see that these are the pivots. And if you look at theorem 13, basis for column A are vectors -3, 2, 3, and -2, 4, -2. It's the ones that the pivots occur in. That's what theorem 13 is telling you. And then they want to have the basis for column for null A. So what you have to do is you have to take that thing, and we're going to have to go on from here. We have to go to reduced echelon form, -3, and let's see. I guess I'll just, I'm going to multiply, what would that be? 6/4, 2/3, right? If I multiply 4 times the -2/3. Three halves. Give me 3 halves. Then that's 6, isn't it? So that's what I'm going to multiply. So then it's 5 times a -3 halves. That's going to be 15 halves negative And I got to join that with a 6. So I got to do 2 over 2. That was a minus. It's a minus 15 plus 12. That's a minus 3s, isn't it? Oh, 9. Okay. Sorry, I don't know what I was doing. Another row again. You're right. So this is 9. Then do it 2 over 2. Then that's 18 minus 15. That's plus 3, right? Okay. That's 0. This is a 4. But then I think I should divide that by 1. Divide it by 4. Get it 1. And then 5/4. So this was 3/2. And 0, 0, 0. Well, what I'm actually doing is I'm going for the null, and so there's really if I do it row reduce it, I should have added a set of zeros, right? Which wouldn't, in all your row manipulations, isn't going to be effective. So now you can do parametric. You can do x1 minus 3x2 plus 3 halves x4 equals it. And this one says x3 plus 5 x4. And then x2 is free, and it's like 1, 2, 3, 4. You gotta have 4 of them. For null, you have to have entries for these 4, right? So then, x1 equals 3x2 plus 3 s x4. x2 is free. x3 is, well, what I'm going to do it this way. x3 is x3. x2 is x2. x3 is a negative 5, 4 is x4, and x4 is x4. So then what you have, you have to make the vector x1, x2, x3, x4 is equal to 3x2 x2 0, 0. It is an x3. 0, 0, minus 5/4. Wasn't there an x3? It's 5/4. I'm getting screwed up here. This is 3x2 plus 3 has x. That's an x2. And that's a minus 5/4 x4. And that's an x4. Okay, now have I broken all this down correctly? This is an x2 and then a 0. Okay. Now I got it. Don't I have it right? So then this is x2 times 3, 1, 0, 0. There's no x3s. Plus x4, 3 halves, 0, minus 5/4, 1. How come it? Well, okay. But anyway, these two are the vectors for the null. Basis for the null A. 3, 1, 0, 0. And 3 has 0 minus 5/4. Did I do all of those right? I mean, this is the right process, as long as I got it. It was 5. This was 5/4, wasn't it? I didn't make a mistake there. That wasn't halves, was it? I don't know. I'm not sure whether that number is right. If that number is right, then this is right. This has to be a 1. Anyway, does that make sense? Basically, what you have to do is, if you're going to get the basis for the column A, then you got to get to the point where you're doing the pivot points. So then you go back to your original equation, and the columns for those pivot points. Those are the vectors for the basis. Then you got to do this. Then you have to do this augmented matrix and get it in reduced echelon form, and then do the parametrics, and then get the parametric equations, and whatever these come out to be, those are going to be the basis for the null A. And then it's a question of, have you done all the addition and multiplication right? You understand the theory behind it. Okay. Well, there's some time left, but I'm not doing any more. I'm done.